Hello and welcome back to Math 1500, Applied Business Mathematics, Connecticut State Community College. Today we're going to be looking at compound interest. In our previous video, we took a look at simple interest. Okay, we talked about simple interest. The only thing affecting the growth rate is the interest rate. If I get 10% per year, each year I get 10% of the original amount invested. It's not a good way to invest. Sometimes you'll find that in certain places. More commonly, when we invest, we look at compound interest. In compound interest, not only do we earn interest on the original investment, but we also earn interest on all of the previously earned interest. So the amount of growth is determined by not only the interest rate, but also the compounding frequency. If you think back to the first unit, we talked about linear functions versus exponential functions. Simple interest, my growth rate is linear. In compound interest, our investment grows exponentially. It grows at a faster and faster and faster rate. We earn more amount of dollars each year, even though we're getting the same percentage rate. Because simple interest is additive, compound interest is multiplicative. So let's look at some compound interest. The future value A of an initial investment P. So again, A is the amount in the future. P is the principal or the present value. Consistent compound interest rate R. R is the interest rate. N is the number of times per year that the interest is paid. And then the compounding frequency. And then T is the number of years that your investment is made. And so you see the formula right here. A is P times 1 plus R over N to the NT. Sometimes you'll see it written as I have it down here, using FV instead of A and PV instead of P. FV for future value, PV for present value. And I'm cool if you use that. I think it's great if you use the FV. I know a lot of finance courses will use the AV instead of A and the PV instead of P. Just know that that's not two different values being multiplied together. So we're going to do some examples here. And I'm going to write my formula again over here. I'm going to use the A and the P. But A is P times 1 plus R over N to the NT. So if I invest $500, that's my P, into an account paying 3% interest, that's my R, compounded annually. Now we're assuming it's 3% interest, so that's annual interest, compounded annually. So that's my N. I wrote T. So my N is 1. The interest is being compounded annually. So how much money will my account be worth in 10 years? So A will be the 500 times 1 plus 0.03 divided by 1 to the 1 times 10. Now with that N being 1, I can rewrite that as 500 times 1 plus 0.03 to the 10th. I'm going to use the calculator. 500 times 1 plus 0.03 to the 10th power. And at the end of my 10 years, I have $671.96. Okay. Little pet peeve of mine, please make sure that you put the dollar sign in front of the number. To know how much my account will be worth in 20 years, 1 plus 0.03 to the 20th is the only change I need to make. So on the calculator, remember, I can cursor up to the previous entry that I want, press enter, and then I can backspace and change the 10 to a 20. And after 20 years, my investment is worth $903.06. After 30 years, A is 500 times 1 plus 0.03 to the 30th. So, same thing. I'm going to go up here. Same formula. I'm going to change my 20 years to 30 years, and at the end of 30 years I have $1,213.06. $0.63. Now, forgive me for doing a little bit of estimating, but remember we had a $500 investment. If I subtract $500 from this, we have $172 approximately. In the first 10 years, we earned $172. If I find the difference between the amount after 20 years and the amount after 10 years, so I'm going to do that 903 minus the 671. That's a difference of $230-ish in the second 10 years. If I subtract the amount of my account's worth after 30 years minus the account the value of it after 20 years, notice that was $310 approximately. In the first 10 years, I earned $170 in interest. In the next 10 years, $230. And in the following 10 years, $310. Notice that the amount of money that I'm earning is increasing each year or each of the 10 years. Okay. Now, here are a couple of different questions working with the formula. Suppose you need to earn, or suppose you need your account to be worth $1,000 in 15 years. What interest rate will you need to earn? And again, we're going to work with the assumption that it's annual interest, so n is 1. So again, that value, that function, 1 plus r over n to the nt, where those n values are 1s, that formula can become p times 1 plus r to the t. So if I need my investment of $500 at 3% interest, what interest rate would I need to earn? I don't know my interest rate. What interest rate would I need to get so that in 15 years my account is worth $1,000? So I'm going to divide both sides by the 500. And 1 plus r to the 15th will equal 2. I need to raise both sides to the 1/15th power, or find the 15th root. So 2 to the 1/15th power is 1.047. If I subtract the 1 from both sides, subtract 1 from that, we have 0.047 or 4.7% interest. I would need to earn 4.7% interest in order for my account to go from $500 to $1,000 in 15 years. Now, part E is a little bit difficult, a little bit more tricky. If the best interest rate you can find is the 3% interest, how long will it take for my account to be worth that $1,000? So my $500 investment at 3% interest, how many years will it take before that's worth $1,000? Again, I'm going to divide both sides by 500. Notice in the parentheses, 1 plus 0.03 is 0.03 to the t equals 2. Logarithms. Here's where I can use logarithms. And I'll do this with the log base, like we've done before. The base of the exponent is 1.03, so log base 1.03 of the 2 is equal to t. So now I can go to math, go down to log base. So the base of the logarithm is the 1.03 of 2. So t is 23.449. So t is approximately 23.5 years. Okay, it's approximately 23.5 years for my investment to be worth $1,000. I know you don't love the logarithms. I do have a solution coming up for you in the next video, so please make sure that you do watch the next video. If the best interest rate that you can find is the 3% interest, how long will it take for your account to be worth $1,600? So again, I'm going to do the same thing as above. My $500 investment at 3% interest for T years, I want it to be worth $1,600. Divide both sides by the 500, 1.03 to the T equals 1,600 over 500. I'm going to make that 16 over 5. You can go to the calculator and do the division if you would like to, but there's no need. Again, log base 1.03 of 16 over 5 equals T. Again, math. We're going to go down to the log base. 1.03 is the base, and that's 16 over 5. If you want to leave it 1,600 over 500, you could, and notice that T now is equal to 39.35. I'm going to call it 39.4 years. It will take 39.4 years for my investment to become worth $1,600. Okay? One more example. Suppose I invest $1,500 into an account earning 6% interest compounded monthly. Notice the difference here is that my interest is compounded monthly. So in this case, when I use my formula, the N is going to be 12. So how much will my account be worth in 10 years? So A, my future value is the $1,500 principal times 1 plus, now I have 6% interest, 0.06% interest, but that's compounded monthly or 12 times per year. So I get 1/12 of that interest each month for 10 years. So notice we have the N's back into this. Now, what I like about this formula when it comes to using the calculator is I don't really need to do a whole lot of pre-calculation, if you understand what I mean. I can just type 1,500, parenthesis, 1 plus 0.06 over 12, close that parenthesis, to the, now I know that 12 times 10 is 120, but I could still be lazy and just do 12 times 10. The calculator will take care of that for me. My investment in 10 years is 27, 29, 10. Okay? Another reason I like that is if you look at part B, what about in 20 years? I can re-enter that formula, or remember that my number of years is no longer 10. My number of years is now 20. And so in 20 years, it's going to be 49, 65, 31. Now, for those of you in Math 1500 with me, with my course that are taking this, and you have a test upcoming on this topic, I will want to see you give me the formula for those where I require the formula. Okay. Just a little tease here, that's what's coming. Make sure you watch my next video, is that we have calculating devices that do this finance math for us all the time. So we're going to do a little bit with the formula and the calculator, and then I have something very valuable to share with you in my next video, so please make sure that you watch that one. How much my account be worth in 20 years if the interest is compounded quarterly instead of monthly? Well, the only difference there is that my amount is going to be the original $1,500, and instead of getting 6% divided into 12 pieces throughout the year, it's going to be divided into 4 quarters. I get 1/4 of the interest each quarter rather than 1/12 each month. So that's going to be 4 times 20, because it's 4 quarters for 20 years. So 1,500 times 1 plus 0.06 divided by 4 to the 4 times 20th power, and that would be $4,935.99. Okay? Now this is going to be fun. How long would it take for my account to be worth $5,000? So we're going to go back to the logarithms. So my 1,500 times 1 plus 0.06 over 4 to the 4t is equal to 5,000. We're going to use logarithms again, We're also going to use the calculator, I hope, in a more powerful way. We'll divide both sides by the 1500. And again, the hundreds are going to cancel. I could go farther, I'm not going to. 1 plus 0.06 over 4 to the 4t is 50 over 15. I'm going to use my logs, and I'm going to use my log base again, where this is the base of the exponent. This is the power of the log base in the calculator. Log base 1 plus 0.06 over 4 of 50 fifteenths is equal to t. I do have a better solution for you again in the next video, but math, go down to option A, log base, and the base of my exponent is just 1 plus 0.06 over 4. The calculator can handle that calculation, except that, oh, that's right, okay, 50 over 15. Now I wrote t, that's actually 4t, because my exponent here is 4t. So 4t is equal to 80.86. So now I'm going to divide both sides by 4. Divide by 4. And my t is 20.2. It will take 20.2 years for my investment to increase to $5,000 if it's compounded quarterly. Right? So there's compound interest using the compound interest formula, calculating it on the calculator. Again, for the third time now, please, please, please make sure that when you do the homework in WebAssign, you're following my directions here, but that you make sure to watch the next video so that you can use the calculator even more powerfully and you'll be well set up for the next test. Thank you very much for watching, and I will see you next time.